Alright, so in this video, I'll be showing you a Spring Boot application deployment in Kubernetes, but we're going to be using AWS to do everything. So pretty much a Spring Boot application is based on a Java framework used to create microservices or standalone production-ready applications with little to no configuration. And so the purpose of doing this is so you will gain the ability to manage the application dynamically while leveraging Kubernetes and scaling capabilities to meet business needs efficiently. So that would be the reason why you would do something like this. So to begin, we will go make a EC2 instance. So let's do that. I'm going to click launch. Just going to name it Spring Boot. Spring Boot app. I'm only going to need one. I'm going to use Amazon Linux. Then for the instance type, we're going to use T2 medium, since there's going to be a lot going on within this EC2 instance. And then next, for the key pair, I have one created already. We'll use that. And then we'll create a security group that allows SSH traffic. So keep that. And then everything else we could leave alone. And we can just click launch. So now the EC2 instance is launched. So now we can click on here. And just brings us to the instance, let us know that it's running. And then I can click on it, click connect, and then click connect here. But I'll give it like a few more seconds. And then I'll click connect. So let's do it now. All right, we're in. So first thing I'm going to do, I want to run everything as root in this case. So what I'll do is I'll do sudo su, which gives me root privileges and makes me root. So that's what's going on here. And then next we're going to update the packages on the system. So I'll be yum update -y. Everything looks good. Move this, close that. And next we're going to install Docker. So yum install Docker -y. And the -y is just, you don't have to ask me for okay to install the packages. You can just do it. And then it looks like it's completed over here. So let me clear the screen and scroll back up. And next we're going to first start and enable Docker. So we need to do systemctl enable Docker. All right, now we know it's on. And then we can just do start, and then last thing is status. All right. So with the output, it's letting us know that it is running and everything looks good. So I can just press Q, out of that, and then just for in this case, let's ask what is the Docker version 25.0.5. So now we know. The next thing we'll do is install contract. So we'll do yum install So contract is pretty much the connection tracking system used for network traffic management within the cluster, Kubernetes cluster. And it just keeps track of network connections and their states, like the IP address, the destination IP address, ports, and then, whether or not something is connected or not. So that's what's going on there. That's what it does. So looks like everything is good. I will clear the screen again. And then now we're gonna install Minikube. And so for that, we need to curl from a specific location. So I do have it right here. So I'll just copy it and then paste it in here. And so Minikube is another thing that's essential while doing this project. So that's why we need to have it installed. And then the next thing, first we sort of downloaded the package. That's my mistake. We sort of took the package and downloaded it so we can have it on our system. And then now we need to install it. So let's do that really quick. Let's see. All right, so it looks like it started now. Oh, it's installed. So now let's do this. All right, so pretty much what happened was I used sudo for some reason it wasn't able to find it. So then when I did sudo install, it looks like everything worked out in this case. So that's what happened there. And then the next thing I did, I started Minikube. And so that's what's going on here. Start, and then force, and then driver Docker. And also, funny enough, if you scroll down on the output, it says the Docker driver should not be used with root privileges. And if you wish to continue as root, use force. So pretty much if I hadn't put -- force in here in the command, it wasn't going to start. So that was the reason why this was in that command. And also because it needed to be in there since we're using Docker as the driver. So we had no choice but to use that. All right. Now that it's done, let's see the version. All right. So we know it's version 1.34. And this is also another way of telling us that, hey, we know it's installed since it's giving us the version. So if it wasn't installed, I'm pretty sure it would give a version anyway. So now we know it's there. And then now we need to curl something else. So let me clear the screen and curl this. All right. So now it's on our system. Now we need to install it. So let me do that. All right, and so here what we installed was kubectl, and so that is also something else that we'll be using during this project. So let's double check if it's there. And yeah, it looks like it's there. And then pretty much just to give, so basically we installed it. We decided where it was going to be within the Linux directory. So it's going to be in usr/local/bin kubectl. So that's what was going on here. So let me clear the screen. And then next we're going to install Git. All right. Everything. Let me clear the screen. But everything looks good. So all right. Now that that's done, now we're just going to do git version. All right. Now we know it's there. So now, next thing we need to do is get to the code that will be setting up a Kubernetes cluster and everything else it needs to run. So we can transition to Visual Code right quick, Visual Studio Code. And then first, since we're on Dockerfile, let's go over this. So pretty much what's going to happen here is that we're going to use the OpenJDK 8 as the image for the Java application. We're going to expose port 8080 so that it can be accessed on that port. Then we're going to copy the built Spring Boot file from the target directory on the host machine to the image root directory with the name Spring Boot -crud kubernetes.jar. So we're going to have add target, and you see that there. And then we're going to specify the command to run the application and execute the Java runtime environment with the -jar option to run the specified jar file. And so, in summary, the Docker file will create a container that runs the Spring Boot Kubernetes application, which will listen to HTTP requests on port 8080. So that's all what's going on here. And then here is the pretty much the Java application. So what's happening is that in this file, it's defining the structure, dependencies, and the build instructions for the application. So all what's in here is a bunch of Java code, and then with each section, it pretty much has a comment of everything that's going on. So that's that. Let's go to the next file. And then the app-deployment.yaml file. What's going on here is it's defining the deployment along with the resources needed to run the application in the Kubernetes cluster. So as you see here, saying the name, the app, what's the name of the container, what's the image it's going to use. Then we're setting the environment variables. Here, we're going to say the version, the Kubernetes resource we're creating, the metadata, what port is going to be exposed. And so all of that is in here. And then next, we have the db-deployment.yaml file. And this will define the resources for deploying and managing a MySQL database in a Kubernetes cluster. So here we have the different sections laid out. First, a persistent volume claim will be made for MySQL storage. This is going on here. Then over here, all of this will be configuring the deployment of a MySQL server. So that's all this code over here. And then next, where you see the 3 dashes, then we're going to be defining a service to expose MySQL to other services. So coming down, you see the DNS name, MySQL, the port that will be exposed, 3306. And so that's what's going on in these 4 files. So we will actually be creating these files. So let's go ahead and do that. So first, what we'll use VI. So we'll do the first file, we'll do db deployment .yaml, and then I'm going to press I for insert, and then we'll just copy and paste everything in here. Then escape :WQ to save, and the next thing we'll create the Docker file. We can do that. And I for insert, come back. Escape :WQ. And then next, we can do the app-deployment.yaml. I for insert, and paste that. And the last file, All right, now that all the files is done, we can start by creating what's in the db-deployment.yaml file. So to do that, I'll do kubectl create -f db-deployment.yaml. So it's saying that the system volume claim /MySQL PB claim was created. The deployment.app/MySQL was created. And then the service MySQL was created. And then just to check to make sure it's running, we can do a kubectl get pods. So we see that its name is MySQL, it's running, and its age is 28 seconds. All right. And then now, since it's running, why don't we make sure that MySQL is installed in there? So what we can do is we need to exec into the container. So when this pod was deployed, it made a container, and in that container, it'll have MySQL. So why don't we do that? So first we need to run kubectl exec it. This just means interactive mode. Now we need the pod name. So we put I actually don't have to type it out since it is right here. I can just copy and paste. Sometimes you just don't want any unnecessary errors. So we'll have that. Then do a dash, then /bin/bash. And so now we're inside that specific container. And then now we can just run MySQL -u root, forgot root, and then -p, then ask them for the password. I enter the password, and now we're in MySQL. So now we know it's there. Why don't we just do something really quick? We can just do show databases, and then we see we have a information schema, MySQL performance schema, Kingdom Labs, SYS. So, all right, now we know everything is there. So we can just exit for now. We don't got to do anything else. And then also exit again since we're still in that container. And then we can clear the screen. I'll scroll back up. All right. That's done. Now we need to install Maven. So I will do that. Do yum install Maven -y. And so Maven is an important part in this because it allows the pom.xml code. It'll set everything up, make sure everything is good. And then also it will allow us to create the Docker file as well. So once this is done installing, we need to clean the package and make sure everything is good. There's no issues. So let me clear the screen. I mean, it should be installed, but we'll do version, make sure, okay. And then now we can do npm clean package. And so basically it's going to look through They should be looking through the pom.xml file and making sure everything is good and everything is set up. That way, when we do our Docker file and install everything else, it should be good to go. So just take a look. This is everything here. And then also another reason why is because if we don't do the Maven clean package, this directory pretty much won't get added. So what will happen is if I didn't do it and I just said, let me build the Docker file, it's going to come up as an error. There will be an error and it'll just say, hey, this location does not exist within the system. And so because it doesn't exist within the system, you can't completely make the image based on what I put inside. So we can go back. So this shouldn't be that much longer. There's a lot going on. So we can just wait. All right, so it's saying build success. So it looks like everything is good. So let's clear the screen. And then now we can do Docker build -t, and then we'll name it as Spring Boot App, and the dot. And then as you see, it's creating the Docker file. All the stuff that was listed within, it's going through it and creating the image. All right, looks like it's done. So now we can do Docker images, and we see that it's there. So now we can clear the screen. And then next, what we will do is I will actually log in to my Docker account really quick. All right, so let's me know I'm logged in, and then now let me do Docker images again. So now that we've done that, now I need the tag. So if I want to push it to the Docker Hub repository and make a repository, I need to get the image ID. So I need to do, well, and also tag it as well. So Docker tag, and then since the image ID is right there, now we got that. Then I just need to put my username, and then Spring Boot CRUD okay ES 1.0. Do that. So now that it's tagged, And then I'm gonna just recall the command, and then just do push, and then now it should be pushed to Docker Hub. So what I can do is go there right now. Do that. And then see, as you see, less than a minute ago, it says it contains a image. And you see it was pushed a few seconds ago. And so that's what's going on there. So now it is there. So we can just go back. And so then now that that is done, what we can do is create the other files that we have in there. So the other file that we didn't touch was the app-deployment.yaml. So why don't we do that? So to do that, we'll just do kubectl apply -f app-deployment.yaml. And so with that, we see the output is deployment.apps/springboot-crud-deployment was created, and then next service/springboot-crud-svc is created. So why don't we clear the screen, and then we can do kubectl and get pods. And then as you see, remember, this is the same MySQL that we had made before when we previously ran this command. And then these are the other deployments, or the other pods that was deployed as well, along with whether it's running, is it ready, how many times did it restart, and then how long has it been up. So now that that's done, what we're going to do is do some port forwarding. And so pretty much port forwarding is just a technique to redirect network traffic from one port to another. And so in this case, for Kubernetes, it just allows us to access services running inside a Kubernetes cluster from our local machine or another remote host. So we need to go ahead and do that. So in order to do that, let's start by running the command. All right. So pretty much what happened was that any traffic in this case 0.0.0.0 was stand for any traffic. So any traffic, it will go to port 8080. So that's what's going on there. And then next we can do something else. So I will Control C out of this really quickly. So it should still continue to forward traffic to port 8080. So now we need to run another command. And this will allow us to open the dashboard of Kubernetes inside our EC2. And as we know right now, Minikube is running. We installed it previously, like let's say 10 commands ago. And we're going to set a proxy for the local address. And the proxy server is going to be on port 8001. So let's do that now. All right. And so now the proxy server is created and it's serving on 8001. And so now that it's doing that, we actually need to leave this instance alone and make another terminal. So simply all we got to do is just go back, click connect, and then we can click connect here, and it's just going to make another session. And so this one is still running, and then we need to use this one. And so now what we need to do, you need to do sudo Minikube dashboard. And so what happens is now it's going to enable the dashboard. It's going to create the dashboard, and then it should give out a URL that we can use to go over there. So now it's giving us the URL. So let's see. So we're going to copy this. In a new tab. And then I'm going to paste it. And then what we're going to do, let's see. Okay. Saying the site can't be reached. So let me do something else really quick. So you should be able to, once you put the URL and everything, it should be fine. We should be able to go to it. But to double check, let me just put the regular URL. See what happens. All right, it still doesn't work. Okay, so what we could do is we can do something else. So let's open up WSL. So what we're gonna do is we're gonna SSH into the instance, and then once we SSH into the instance, it's still going to be running. Everything is still going to be running. So then we can try to go to the URL then. So let's do that. So first we're going to do SSH -I test pair .hem -uppercase L. I'll do 8001. Then the IP address, so 127.0.0.1. Then :8001. And EC2-user at, and then we need the IP address. So if we go back and get that, and then just for reference, if we click connect and then SSH client, this is actually where I'm getting the command from. Funny enough, I'm just using this. So if that was confusing, so then now just go back. And I don't know why it's not pasting. Let me see. If I do this and go back, it should be copied. All right, let me copy it again. All right. Now that it's there, let's see. I need to say yes. All right, now we're in the EC2. So then now let's try this. We can do localhost 8001. Okay, so now it gave us this, but this is not the dashboard that we want to be looking at. So let's see what else we can do. Okay, so you know what? Since we see that it's here, it is bringing us somewhere. Why don't we try the URL again? So we're just going to go back to one. We're going to go back to this, and we're going to copy the URL of the instance, and then going to paste it, and then we're going to change the port number to 8001 because that was the one that was specified. And then let's see. All right, so now it actually worked. So now we're at the dashboard. So this is pretty much the Kubernetes dashboard that you will see. So just staying on this page, we see that we have, 2 deployments. We have our MySQL application, that's a database. Then we have the application that was deployed. Then we have our pods pretty much that was deployed as well. So we have that. And then MySQL, Spring Boot applications. Let's see what it used. It used MySQL, etc., etc. What node did it use? It used Minikube. Is it running? How many restarts? Etc. And then we have replicas. So this is, just in case. Hey, what if one of them goes down? And, in this case, in a production environment, you wouldn't want everything to stop all of a sudden. So we have replicas just in case anything goes wrong. We can still access our services without any issues. And so that pretty much brings an end to this project. So just to overview really quickly, we used AWS. We made an EC2 instance. We installed different packages like Minikube. We installed kubectl. We installed Git. We installed Docker. We did all of that. Then we made different files like the Docker file, POM, the XML file, the app-deployment.yaml file, the db-deployment.yaml file, which all of these played a part in creating our pods, our applications, so that we can get to the dashboard. We did some port forwarding, redirecting traffic from one place to another. We made a proxy server so that we can access it. We can access the Kubernetes dashboard inside of our EC2 instance. And then also as well, we also SSH'd as well, since the dashboard, it didn't appear when, I copied and pasted the URL, but it did appear after I SSH'd into the EC2 instance, then put the same URL and then also changed the port. So more than likely that was probably why it didn't come up. And then also, if you remember, when I SSH'd in and then I did localhost 8001, it showed a bunch of text. So yeah, that will pretty much end this project. I hope you've gained some type of knowledge, if anything, from it. And I will see you in the next video.